Greetings everyone. This is Shubham Raut and me and my group members here under the guidance of Sujit sir are presenting this project on a smart stick implementation for visually impaired using YOLO. Now, as we can see, the world is advancing with technology in various fields, and so we just thought we can use our knowledge to implement in such a similar domain to help visually impaired people. So, in this, we have observed, we observed that visually impaired people just do not need to detect a hurdle or an obstacle in front of them, but it is often many a times necessary for them to identify the object. It is important for them to interact with the object to make their for example, if in a room full if in a room a blind person walks in and he has to take a bottle from a table. Now it is not only important for him to identify what are the obstacles in his path towards the table on which the bottle is placed, but also to determine the distance and also identify whether the bottle is actually there on the table or not, to identify the bottle. So it is the entire uh, aim of our project could be summarized that we are not just uh, not just focusing on hurdle detection or obstacle detection, but we are also implementing obstacle identification. Now we are there are various similar projects that have been presented previously on smart sticks, but they implement AI algorithms and not machine learning. We are implementing learning algorithms that is YOLO. You only look once, which is a very fast algorithm that will really bring down the response time between the processing and the output that is received by the user. Now, so here are the literature surveys that we saw that there were previous projects that were based on smart stakes, but none of them implemented using YOLO algorithm. So our main project here is to show how YOLO is a very efficient algorithm to be implemented for smart stick. Now, I would like to further give it away to Mukta to explain the hardware components and everything.
Hello. So basically now I'm going to explain the architectural diagram of the system. So we have divided it into three parts, that is input, process and output. So here in the input we are going to give Raspberry Pi camera module. So now the camera module will contain all the images. So we are going to give a database and ultrasonic sensor. So these parts come under the input. Now the process. So we are going to need images for training the module and testing also. So now in YOLO, what will happen is one image will get divided into many boxes. These boxes are called as bounding boxes, and each box will have the dimensions as length, breadth, width, and height. That is, which is also called as convolutional grid. So now, if the object or any part of the object is present in that box, then the probability of the object being there increases, or you can say as confidence score. And based on the total confidence score and the total 2D class probabilities, as we call it, the final result that the object is present or not, we will get it there. And then by using the voice synthesizer here, the model TLC 5615CP, very good model, we are using this, and through earphone we are going to get the results. So this is the sequential diagram, how the things are going to process: ultrasonic sensor, Pi cam, Raspberry Pi, and phone, and image capture, that which I have explained it. So here SDLC model, we are using the spiral model. Now we use spiral model because, so these are the use cases, different cases we considered during this. The how how the login and register of it, and how the system in the phone will be done, and then the distance and calculation of the distance between the object and the user, and the collision. So all this we are going to do, and maps and voice input is the future scope. Then mathematical model, now this is the main part. So PC, now PC is the main main part of it. So PC will tell whether the object is present or not. It is represented in binary code, 1 or 0, yes or no. So on how is this calculated? It is calculated by the bounding boxes which we discussed earlier. So Bx, By, Bh and Bw. So length, breadth, height and width. Uh, these are represented by it. And C1, C2, C3 are class probabilities which we saw. So as this probability increases, then we get the PC. Okay, so now Mayuresh will continue.
Yeah, so I'll be going through other alternatives of YOLO, and hence I'll be discussing why we decided to go with YOLO. We decided to go with YOLO because YOLO is much more faster than any other algorithm, object detection algorithm available in the market. There are three other algorithms which can be used for object detection, and those are RCNN, fast RCNN, and faster RCNN. I'll be going through this algorithm quickly. RCNN stands for regional CNN, which means that this algorithm solely focuses on the region extracted from the image. Instead of dealing with huge number of region, this algorithm only deals with 2000 extracted regions, and these extracted regions are then fed to CNN, and the features are extracted from this region. Then these features are extracted to SVM to classify whether the object is present in the candidate region or not. Even though this algorithm may work efficiently for smaller images, it takes huge amount of time to train because it has to classify 2000 region per image, and also it takes around 45 seconds for each test image, whereas in case of YOLO it classifies image as 45 it works for 45 seconds per frame, so which is much faster than RCNN. Also, the another drawback of RCNN is that it uses selective search, and due to this there is no learning happening in this stage, so it may result in bad candidate selection or generation for that matter. Faster RCNN is available. Instead of using selective search, the algorithms like RCNN, faster RCNN, it uses the entire new neural network to convert the image into convolutional feature map, and hence this feature map is used to extract the region of proposal and then perform any identification or detection on these images. Therefore, the faster RCNN can also be used in real-time applications and is faster than other two algorithms. We have also created a demonstration which will be shown by Varad.
We will be using a software called as Flow Master, which uses a YOLO algorithm to train and detect the objects and the images. For the model to detect and identify an object, we first need to train the algorithm to perform highly accurate calculations. To train the models, we need several models with that particular objects. After getting those images, we use a software called as Label IMG. This software is used to draw the bounding boxes around the specific objects and label its class. Here we are labeling its class such as persons of our laptop. While saving the files, two files are created. One is the input image containing the bounding box around the object, and the second is the annotations, which displays the dimensions of the bounding boxes in that image. After we label these images, we use a command that detects the dark flow to train on these given images. After several hours of training to several thousand images, a new model is created and an algorithm is generated. This model can be then used for testing the images. The model can be used to test static images already stored in the system or dynamic images to the webcam. The text is then read from the screen using screen memory. This process may take a few seconds or a few minutes depending on the computational power of your PC. Here we have tested our model on static images, and you can see the results on the images we gave them. This is the output